Hello, people, and welcome back to another session. In this session, we'll be going over an example of one-way analysis of variance using R. So, in the previous sessions, we have seen all the aspects of one-way ANOVA. We have seen the global F test and we have seen the pairwise T test to basically find evidence against two sets of hypotheses. First, whether there exist differences among at least two groups out of the K groups, and secondly, which of the two groups are actually distinct from one another. So now in this particular session, we'll be going over an example and we'll be doing it using R programming. So we have a data set. We have a data set called smokers data set. And this smokers data set basically consists of four types of smoker groups. It has current heavy smoker, current light smoker, former smoker, or people who have never smoked before. It has the age of smokers and the systolic blood pressure. So what we need to find out as per our question, we need to find out if the mean systolic blood pressure differs across smoking status categories. This is what we need to find out. So our in our question, the measure for the measure that tells us whether group differences exist or not is my systolic blood pressure. So what I need to figure out here, if I had to write my null and alternative hypotheses, my null hypothesis is going to be, since I have four groups of smokers, and my alternate hypothesis will be, this is my null and alternative hypothesis for this particular situation. And now let us go to R programming and start seeing the code. So as you can see, this is my data. Now there is the column that represents the groups, which shows heavy smoker, light smoker, former smoker, and no smoker. That particular column needs to be a factor column. So we need to see whether my group column is a factor column or not. It is not a factor column. So I have to change this particular column into a factor type. So I'll do that by using the R function as.factor. There is an aggregate function which basically takes the argument of a numerical argument, it takes on a list argument. The list argument basically is used to do a group by operation. So if you want to see some kind of a summary on your numerical variable, but you also want to see it for each of the groups, then you use the aggregate function. So here we need to basically look at the summary aggregate of systolic blood pressure by the by the groups of smokers. I'll push it a little to this side. This is my values for all the groups. Similarly, if I have to see variance for all the groups, I'll write the code like this. For a more visual representation, we will use box plot. Now for box plot, because I have to show the box plot of systolic blood pressure, but I have to show it group wise, which is why I'll write the code as systolic blood pressure tilde the group. There it will generate my plot something like this. This is the box plot of the systolic blood pressure for each of the groups. Now comes the main part. Now basically we need to conduct a one-way analysis of variance on systolic blood pressure being the primary measure, and our groups are present in the group column. We need to see, based on the measure of systolic blood pressure, do we have differences among smokers? So the syntax in case of an one-way analysis of variance for a data set is AOV. This is my function, my numeric variable, tilde, my factor variable. This is the general syntax. Now, please do not confuse this AOV with ANOVA that we studied when we were studying simple linear regression and multiple linear regression. Do not confuse these two. Remember, ANOVA generates the ANOVA table. AOV has a similar function to what LM did, where it basically creates a one-way analysis of variance model. So here you can see once I create my one-way analysis of variance model, I'll show the summary. Now for the summary, you can see, first you can see the degree of freedom for the group and the residuals. So the degree of freedom for between and within we studied are k minus 1 and n minus k. Here, if I go back to my data set, I have 19 rows. So n will be equal to 19. I have 4 groups. So my degree of freedom for between would be k minus 1 and for within will be n minus k. Therefore, this is 3 and this is 15. My sum of square between is much higher than my sum of square within. Same goes for the mean square. This is basically this divided by this. And finally, my F value is this divided by this, which is MSB by MSW. I'm getting it as 21.49. And as you can see, the P value is extremely small. And an extremely small P value in general suggests that we have sufficient evidence against the null hypothesis. But if the question would have given a significance level, then we could have calculated the critical F value on that significance level using k minus 1 and n minus k degrees of freedom. And then we would have compared the F statistic value with my critical F value to see the final result. But in general, we can surmise here that because of a very small p value, we can reject the null hypothesis, and there actually exist differences at least among two groups of smokers. Now we need to go ahead and figure out which of the groups actually differ from one another. For that, we need to conduct the pairwise t-test. In our previous example, we had taken a similar situation in our Nike, Callaway, and Titleist example, and we had manually calculated using mathematical formulas. But in R, you have a direct way of doing that. In R, you have a function called pairwise.t.test. Now, what this pairwise.t.test does is that it takes in your measure, it takes in your group, and it takes an adjustment method. Now, what is this adjustment method? I'll come to this particular topic in a future session, but for this session, using pairwise.t.test, you can get your results for all the different groups which are present in your data set. So if I run this, so you get an output like this. Now you can, if you see this output carefully, this is, I'll just run this once again because I think this is getting congested a bit. Yeah. So the pairwise.t.test function in R, it it gives you the resultant p-value of the comparisons between different groups. So for current light smoker and current heavy smoker, if you do the pairwise comparison, this is the resulting p-value. And this p-value is calculated from the t-value that we saw using that formula that we use for pairwise t-test. So you can see a heavy or a very high p-value for current light smoker and current heavy smoker, extremely abysmal value for former smoker and current heavy smoker, again a very small value for former smoker and current light smoker. Basically, all these values are quite small, so never smoker is different from all the three. Former smoker is different from all the three. There is no difference between current light smoker and current heavy smoker. So the pairwise.t.test function, it gives you the output of pairwise comparisons directly in one single table, and you can surmise your results from that table. So this is a much faster method of solving questions on one-way analysis of variance rather than going and doing mathematical calculations manually for all the groups. So this was an example in R for one-way analysis of variance. We'll continue our discussion in the next session. Thank you for watching.